Hello, my name is Kenneth, and I'm going to show you how you can relate, how similar triangles are always going to be proportional to each other. So first, we're going to take a look at the triangle that we have now, and we have a triangle ABC, and if we go ahead and we're going to make a triangle that is proportional to it, we're going to take a point and say, I'll go here. And then we have to make a line parallel to one of the two sides that we have. So I'm going to go ahead and make it parallel to line BC. So I'll take my point and the line I want to be parallel to. So now it made a line that's parallel to it. And then we have to make the point, an intersecting point here. So go to intersection tool and we make that point. So now we have point E. Now, we're going to measure the distances between all of them so we can find out the lengths of each one. So I'm going to start off by measuring from A to B, and then I'm going to go from B to C, and then A to C. And then you see we have a 6, 8, and 10 triangle. And now we're going to do the same thing, but we're going to measure the triangle that we made that's similar. So we have to go from, so how we went from A to B, now we go from A to D. We can go from D to E, and then A to E. And you see that we get our famous 3, 4, 5 triangle that we normally use for the Pythagorean theorem. So what we're going to do now is we're going to put this into the formula. So we're going to have our R1 equals the distance of point A to B, so A comma B, over the distance of the distance from A to D, because they're both on the same side. So those two are what's going to be similar to each other. So that's the side of it. So A to D. So we see is 2. So we're going to go to do the same thing, R2 for the other side. So then we're going to do our distance from B to C. Then our distance from D to E. And again, 2. And then lastly, our last side, we're going to go from this distance A to E, A to C, then distance A to E. So, and you see that they all are 2. And now what we could do, we're going to go and go to our move tool. And as we move it, you're going to notice that no matter how we move it, the proportion of it won't change. So we go ahead and move A. They're always going to be, the bigger triangle is always going to be 2 times bigger than the smaller triangle. And then we can show this to use it to solve other problems. So just like we have this problem right here. We have a kid, well, you have yourself, and you go outside and you want to know how tall the tree is. You know how far the shadow of the tree, which we got, was 8.5 meters, and we know how long our shadow is 1.4 meters. And then we take our height at 1.6 meters. So we just right there we created two triangles that are proportional to each other. And so when you have that, you're going to go ahead and set up a formula. So you have 8.5 meters over 1.34 meters, because that's both the length of the shadow or bottom of our triangle. and then you want to take it and you want to take the height of the tree, which we don't know, over the over your height. And then we will go ahead and cross multiply. So we have 8.5 times 1.68, which will equal 1.34x. And we come out to 14.28 over 1.34 will equal what x is. So x comes out to make the tree 10.66 meters.